That was a great opening. I'm Ron Siga, and it's my pleasure to introduce our next speaker, General Willie Shelton, Commander of Air Force Space Command. Now, here most know his role and background, but not all. So I'll go briefly through that. He's responsible for organizing, training, and equipping and maintaining mission-ready space and cyberspace forces and capabilities for North American Aerospace Defense Command, U.S. Strategic Command, and other combatant commands around the world. He also oversees Air Force network operations, manages a global network of satellite command and control, communications, missile warning, space launch facilities, and is responsible for space systems development and acquisition. He leads more than 42,000 professionals assigned to 134 locations worldwide. He's not new to this area. General Shelton entered the Air Force in 1976 as a graduate of the U.S. Air Force Academy, receiving a Bachelor's of Science degree in astronautical engineering, and later earned a Master's in Astro from the Air Force Institute of Technology. I've had the pleasure of bumping into and working with General Shelton over decades, where he's had various assignments, including research, development, testing, space ops, and staff work, and has commanded at the squadron, group, wing, numbered Air Force levels, and served on staffs at major command headquarters, Air Force headquarters, and the Office of Secretary of Defense. Now, he's had a number of assignments in space, and I think kind of uniquely preparing him for his current job, and the results that you've seen over the last couple of years kind of bear that out. He's been a launch facility manager and launch director at Vandenberg, a space shuttle flight controller at NASA Johnson Space Center, commander of 2nd Space Operations Squadron, the 50th Ops Group at Falcon, now called Schriever, director of requirements, plans and programs, Air and Space Operations at Headquarters Air Force Space Command here at Peterson, director of capability and research integration, plans and policies at U.S. Strat Command in Offutt, commander of 14th Air Force, part of Air Force Space Command, and commander of Joint Functional Component Command for Space at U.S. Stratcom, and his position was located at Vandenberg Air Force Base. And prior to assuming this assignment, his current position, General Shelton was the Assistant Vice Chief of Staff and Director of the Air Staff for the Air Force in the Pentagon. Please join me in welcoming the Commander of Air Force Space Command, General Willie Shelton.
Well, thank you, and especially, Ron, thank you for that very generous introduction. It's always great to be here and be part of this symposium. So many friends, so many colleagues in the space business. Space Foundation just does a tremendous job every year in putting on this symposium. Last night, as I was watching the film that Northrop Grumman had prepared, it really kind of touched my heart a little bit and made me just very proud to be part of this business. And I hope you have that same pride in what we get to do for the nation and in support of the nation. I got to take a little bit of an aside for a second and offer to the Space Symposium, to Elliot and to Marty Fega and to the board, offer my apology on behalf of the federal government that we can't have everyone here that we would like to have here. I think everybody understands the financial situation and why those decisions were taken to not allow people to travel here from the various government agencies. But I have to tell you, personally and professionally, I find this very embarrassing. So my apologies to everybody here, for everybody that would like to be here but couldn't. 2 years ago, when I addressed this group, I began what I would consider to be a conversation with all of you. And it was about the U.S. military reliance on space. It was about increasing vulnerabilities in the space domain. And it was about affordability of our programs. Even then, we could see that times were going to turn down, that our budgets were going to go down. And so we were going to have to try to achieve what at that point I called the nexus of sufficient capability, affordability, and resilience. I want to continue that conversation today and maybe highlight some things that we're doing in that regard, but probably even more important today than it was 2 years ago. I'm going to be strictly talking about national security space. There are other speakers that will talk about commercial and civil space, but I'll focus on national security space. So let me talk about reliance first. Every military operation, I'm going to be very bold, but I really believe this. Every military operation, no matter how small, no matter how large, all the way from humanitarian operations, all the way through full-scale major combat operations, depend heavily on space operations and space capabilities. It's deeply integrated into our planning, into our logistics systems, and into execution of operations. So we depend on these very fragile spacecraft, these technological marvels that have been designed and built by geniuses in our nation and provide capabilities that are just second to none. But architecturally speaking, we're very thin. Just enough capability to get us by. To me, it's kind of like mountain climbers. It's like mountain climbers who depend on a very thin rope. They're all hooked together in this very thin rope. And it really is all about the safety of the team. Now, admittedly, this is a well-designed, braided, proof-tested, very strong rope. And the team has lots of confidence that this rope is going to support them when they need that support. But that team wouldn't trust a very frayed or a weakened rope. They wouldn't have that same level of confidence. So now let's talk about vulnerabilities that we have currently, and we see vulnerabilities even more importantly coming in the future. It's clear to me, and I'm sure it's clear to you as well, that our operating environment in space has fundamentally changed. And it continues to change and will continue to change into the next decade. To me, there are storm clouds that are on the horizon. Space was once a benign, much less crowded place. No longer true. Right now, we're tracking some 23,000 objects routinely. Our models tell us that there are over 500,000 man-made objects in orbit today. 500,000. That says that we're tracking less than 5% of those objects on orbit. Why is that? Well, our sensors are just not able to pick up objects any smaller than those 23,000 objects and reliably track them. But as this audience knows, F still equals ma. And even those particles that are small, maybe just 2 or 3 centimeters in size, it doesn't take a whole lot of mass at orbital velocities to generate a whole lot of F, okay? And I talked about those fragile spacecraft. These represent catastrophic threats to our spacecraft. So we've got to pay a lot of attention to orbital debris, and we've got to get better. We've got to get better in debris mitigation. We've got to get better at tracking these debris. Counterspace developments by potential adversaries. We know that many potential adversaries are out there actively working on all sorts of things, from jamming capabilities, both satellite communications jamming, GPS jamming, to dazzling of optics by lasers, to kinetic kill anti-satellite weapons that they are developing. These aren't just imagined threats. Remember the Chinese ASAT test in 2007. A successful ASAT test, by the way, unfortunately generated thousands and thousands of pieces of debris, which we're still dealing with today. We just had a recent conjunction between a piece of that debris and a spacecraft that was non-maneuverable. And those 2 objects got to within about 23 meters. That's close. That's close. And we'll keep dealing with that problem over and over for decades. We also have to deal with the potential of premature failure. We like to believe that we've designed out single-point failures, that we've done a good job with redundancy. But any in the audience who think that we've been totally successful in eliminating premature failure as a problem probably just hadn't been around long enough. We've got budget challenges. I'll be advocating for space, but there will be lots of other people just at the Air Force table advocating for their priorities as well. So it's going to be a very difficult time over the next few years here as we decide what our new priorities are with reduced budgets, what our new strategies are across the Department of Defense. And we clearly have changing environmental conditions. We've got counter-space weaponry. We've got those budget constraints. This certainly seems like the potential for a perfect storm to me. So we've got some very tough choices ahead. Certainly, status quo is an option, but to me, it's not a very good one. I think we're at a fork in the road. I truly think we're at a place where it's a fork in the road for all of us. I love the Yogi Berra quote. He said, when you come to a fork in the road, take it. Well, we're gonna have to take one of these directions, status quo or do something different. This time that we're in, to me, absolutely begs for change. We've got requirements for Air Force space capabilities. We've got protected communications, wideband communications, missile warning assets, GPS capability, weather satellites, space situational awareness, launch capabilities. But at the same time, these required capabilities that we know we depend on, we also know that our operating environment has radically changed. The budget pressures are here, and trust me when I say they will get worse. We're looking at declining budgets as far out as we can see. That's what the law says now, and that's what we believe is actually going to happen as Congress enacts yearly budgets. We must, absolutely must, because of the changing operational environment, become more resilient. We've got to become more resilient from intentional things that might happen to us in space, in the national security realm, and things that might be accidental in nature. My challenge, our challenge, I believe, is to get to the capability, to get to affordability, to get to resilience simultaneously. Right in the middle of the intersection of this Venn diagram is what I would call the nexus, or the sweet spot, or call it nirvana, the slam dunk, the home run, whatever you want to call it. It's that intersection of capability, affordability, and resilience that we've got to get to. But how do we get there? Well, let's talk about those required capabilities for just a second. In protected comm. In the future, we're looking at the advanced extremely high frequency satellite. We depend on this satellite system in existential circumstances for the United States. When communications from the President and the National Command Authority has to get through to our forces to execute options in circumstances that are just at the worst imaginable, this is the system we depend on. We've got 2 on orbit now. We have contracted through AEHF 5 and 6. But what are we going to do beyond that? How do we get more resilient in this system? Our wideband communications, wideband global satellite system. This is dedicated military satellite communications. It's now international in nature. We've got international partners signed up with this. In fact, the Australians have purchased a satellite to buy into the system. We've got 4 on orbit. The 5th will be launched hopefully next month. We've got plans to go through 10 WGS satellites. Missile warning. The space-based infrared system is the system that we're developing here for the future. Our 2nd GEO was just launched last month, and again, this is a satellite system that has to operate in existential circumstances to provide the decision space, to provide the warning, to provide what the President needs to make his decisions on response options. We have that satellite system planned through 5 and 6. We've also got the highly elliptical orbit SBIR systems up and operating now. But again, what do we do beyond 5 and 6? Our GPS system, very robust, doing extremely well. 2F04, it will go up next month, the 4th of the 2F series. GPS 3 will begin launching in FY15. We've gone on contract 1 through 8 of GPS 3. What we do in 9 and beyond is under discussion right now, our acquisition strategy for that. But GPS will continue to be the worldwide standard for precision navigation timing capability. Weather satellites. Our Defense Meteorological Satellite Program has been in existence for many, many years. It is absolutely a workhorse. We've got 2 satellites left in the barn. We'll launch F-19 next year, F-20 probably in the 2020 timeframe, depending on how that plays out, because it will be a launch on need sort of situation. We're in the midst of an analysis of alternatives right now to determine what the next weather satellite will be. I can assure you this, it will be a much smaller satellite. We will press for that very hard for lots of reasons. In space launch, our expendable launch program has been a success by any measure. A wonderful, wonderful operational success, but at the same time, very expensive. We've got a block buy strategy that we're implementing for next year that will provide cheaper launch capability, but again, still expensive capability. New entrants are coming into the market, coming in with new ideas, new concepts, new manufacturing techniques. We'll see how that goes, but we are on a path to encourage new entrants and to certify them to do national security launches. Space situational awareness absolutely underpins all that we do in space. From launch all the way up through space operations, we depend on SSA to let us know what's going on in the space environment. We're developing, I talked about the orbital debris that's just too small for us to track. We're developing a new space fence, a new radar that we'll put on the island of Kwajalein, which will get after some of those lower inclination objects as well as the smaller sized objects that we need to get to. We're also looking to develop a space-based space surveillance follow-on. We've got 1 dedicated satellite on orbit right now that does space surveillance for us. We'll look at options for a follow-on satellite because we have been convinced that this capability just absolutely has to be. In terms of systems to help us with space situational awareness and provide command and control capabilities as well, the Joint Space Operations Center out at Vandenberg is operating on very old technology. You've heard that story before. 1980s computing technology. Last major upgrade to the software was in 1994. I think it's time for a change. We have just gone into the trial period. We're just about to, in fact, we've declared IOC now, initial operating capability, for increment 1 on JMS, the JSPOC mission system that will replace that old hardware and software that's out there in the JSPOC. And we will get increment 2 fielded in FY16 and do incremental fieldings along the way between now and FY16 and beyond. So that's the capability story, what we're working on. Let's talk about resilience. What do we mean when we say resilience? I got asked that question just yesterday. It's kind of like the former Supreme Court Justice Potter Stewart said about his threshold for obscenity. I'll know it when I see it. But we know what we mean by resilience. We know in our guts what we mean by resilience. It's anything that makes us more survivable, that lets us survive some of those vulnerabilities that we talked about earlier. But right now, our architectural approach is just enough capability and just in time. That is certainly not resilient. We talked about AEHF and SBIRS being critical for national survival. We don't have anything beyond the 4 satellite orbit 4 satellites on orbit constellations that we have planned right now. So if one of those satellites fails prematurely or someone takes action against it, we don't have a fallback plan. We've got Space Modernization Initiative funding identified to help us work the studies that will get us to much more resilient capability. And it's absolutely crucial, even in these difficult budget times, that we protect those funds to allow us to have the study money we need to go after those kinds of concepts. We've talked before in this forum about disaggregation. Can we take those big satellites that we have on orbit, those satellites that are costing us somewhere in the neighborhood of $1.5 billion? Can we disaggregate the capabilities on those? AEHF, for example, can you separate the strategic and tactical comm payloads and perhaps create multiple satellites, perhaps even host the payloads on commercial assets? Can we form commercial partnerships and leases that would get us to a very different kind of architectural approach, particularly for wideband communications, rather than having dedicated military satellites accomplish that for us? In the space protection area, we've got a new program. It's really not a new program. We used to have the Space Protection Program Office that oversaw some of our seminal work in this area. Now we've got an office called the Space Security and Defense Program, which is much more robust than just the SPP was. And it will get after some of those studies, some of those ideas about how we can provide space protection capabilities for our forces. Again, SSA will continue to be extremely important, as well as the JSPOC mission system in terms of providing space protection and resiliency. Affordability. How do we get after affordability? Well, I think one way is that we can lower the complexity. I'm not talking about lowering the capability, but if we get after concepts like disaggregation and hosted payloads and things like that, we can lower the complexity in our satellites. We can go after technologies that already have high technology readiness levels. High TRL, less complexity, those are good prescriptions for affordability. We can look at commercial buses. Rather than tailoring each bus to the payload that it's going to carry, go after commercial buses to provide the capability we need. Smaller satellites means smaller boosters, which means less costly. I'll tell you the truth, there's a whole lot of study that's still required, and we're doing that study. That's why I said those Space Modernization Initiative funds have to continue, and we'll continue to get after some of these affordability and resiliency concepts. One of the big problems, though, will be overcoming the naysayers that are out there. There are people that believe that the status quo is adequate. I certainly don't know what intelligence they're looking at. I certainly don't understand what operating environment they think we're in. I certainly don't understand what budget climate they think we're in. But the status quo, to me, just doesn't seem to be reasonable for our future here. So let me wrap up here by asking these questions. Is that nexus really achievable? Is there a nirvana out there that we can realize? I'll tell you, we can't compromise. We cannot compromise on mission assurance. Dollars spent on mission assurance are very cheap in the wake of a failure. When you look at the lost capability, the lost investment, the opportunity costs, certainly, and the operational limitations that those will impose, mission assurance looks very cheap. So I will continue to advocate for continued mission assurance. The die is cast on many of these programs through the mid-2020s, in some cases a little bit beyond that. So we've got a period here. I talked about that fork in the road. We've got a period of time when we can look at what are our architectural options for the future and what should we pursue. Our study contracts for alternative architectures are on the street, but the continuing resolution and sequestration have certainly slowed us down in that area. We'll continue to get after those study contracts. These are some extremely difficult choices for all of us. But history says that we can do this. We can get after affordability, resiliency, providing that required capability. And I got to tell you, if this little guy says we can do it, I know we can. Just look at that grit and determination. Now, for those of you who are old enough, you remember the opening to the TV show, The $6 Million Man. So paraphrasing a bit, we have the technology. We can rebuild these architectures. Better, stronger, more resilient, more affordable. I thank our industry partners who are walking this journey with us, trying to help us determine what the future looks like and how we can adjust to that future. Thanks again to the Space Foundation for providing this forum, for providing this wonderful opportunity for the space business all to get together. And thanks to all of you for your attention this morning. Thank you.